Hello geometry students, today we are going to learn about sine and cosine ratios, and in last video we learned about tangent ratio where we use both of the legs, but this time we are going to use one of the legs and the hypotenuse. So this time either this and this, or it will be either this or that. So that depends on which ratio we're trying to find. So let's move to the next part. Here, if we're trying to find, if we need to find sine ratio for sine, and I already told you for sine the expression is, our expression was so ka toa we used, so it is so and ka toa. That's the expression. Toa we already done, and here we need sine and cosine. So here it is going to be so, and if I have to find the sine of acute angle A means it's going to be opposite leg over hypotenuse, O over H, opposite leg over hypotenuse. So for this one, opposite leg is this one, and your hypotenuse is which one? Your hypotenuse is this. So what is it? You just write down that it is going to be BC over AB. Here you can see that it is BC over AB. Alright, so that's given here, BC over AB. Length of leg opposite to angle A over length of hypotenuse. That's sine ratio for angle A. What if I'm trying to find the sine ratio of I'm trying to find the cosine ratio of angle A? So let me just remove it here, this thing, and show you again. If I have to find cosine ratio, so cosine, I told you cosine is ka. Ka means what? Adjacent leg over hypotenuse. Length of leg adjacent to angle A over length of hypotenuse. So what we need to do, for A, if this is here, so our adjacent leg is going to be this one, so that's AC here. You can see this is AC is here, and then I have to use the hypotenuse. So hypotenuse is where the hypotenuse is going to be this one. So now I need this over that, so that's AC over AB. So that's one example here, how to find it if I need to do it. So I'm going to give you one more example. Suppose this is my another right triangle. Alright, this is my right triangle, and I'm trying to find out here. Alright, this is my, let me just make it properly, doesn't look right. Yeah, that's a right triangle. And if I'm just trying to write down, if I'm taking my angles here, if I say the angles are, this is P, Q, R. These are my angles. If I say sine P, sine of angle P, or you want to say, okay, if I want to find that for this one, if I need to find it, so this angle, my sine is, what is my sine? So expression, it is so, this is opposite over hypotenuse, O over H. I would be writing O over H. Opposite is RQ over PQ. So this is our O and this is our H. Alright, but if I say, okay, I don't want the sine for angle P, I want the sine ratio for angle Q. So if, let me write down here, if I want to sine for angle Q, for Q is here, and my opposite is going to be this one. So in that case, opposite over hypotenuse, so, and that's going to be what? PR over PQ. That's my for that. Now if I want to find my cosine ratios for all the two acute angles, so that's going to be cosine, that's going to be cosine of angle P and cosine of angle Q. And cosine we know K, A over H, A over H. For angle P, you have to look for this angle, what's the adjacent leg? It is this. This is the adjacent leg. That's going to be what? PQ over, hypotenuse is the same, so that's PQ. And for angle Q, if I'm just going for angle Q is here, that's my angle Q, and the adjacent leg is this one, so that's RQ. So I'm just writing this, RQ over hypotenuse, H is PQ. So one thing for sure, you must be paying attention that for a same triangle, when you look for your any ratio for sine and cosine, your bottom is PQ. That's always hypotenuse. Only the top part is changing. That depends on where your angle is located, that adjacent leg is used. So this way we can find sine and cosine ratio. Please let me know if you have any question. I would try to help you. Stay safe. Thank you and bye.